How do I get that big?
It should be bigger, yeah.
I think it just popped up before.
It's still... We're recording too, right?
Yeah. We'll edit this out. There we go. All right, ready to start?
Ready whenever you are, man.
Hey guys, it's Mr. Baldwin.
How you doing? This is Mr. Z.
Mr. Marsalis.
Mrs. Guest.
And we're going to start working on our first video for geology this year, so it should be a pretty good one. So every video you're going to see is going to start with a slide that looks something like this. It'll have an essential question. So like we see here, we've got how do natural hazards, features, and human influences impact the Earth's spheres at different timescales. And then after that,
we have our learning targets, and this is something that we've already talked about in class. We've already done our online document and rated ourselves, and we're going to be tackling all of these learning targets in this video today. If you go back to the essential question from before, we talk about natural hazards, features, human influences impacting the Earth's spheres, and we go back to the learning targets. We can see that question is then broken down into those learning targets.
all right, so I'm bored of hearing you talk, Mr. Z, so let's move on. So what we're going to start with is defining some of the spheres. So we've got 7 spheres that we're going to work with in geology class this year. Any of these look familiar to you guys?
Yeah.
Atmosphere. Atmosphere. I think I know the biosphere.
Yeah?
Yeah.
What do you think about the hydrosphere?
Hydro, I think of water.
Perfect, cool. So if we define some of these guys, we've got these 7 spheres, which atmosphere, biosphere, you guys have seen before. Hydrosphere, same thing. You might have heard of a cryosphere. Think frozen, like cryogenically frozen. So it's everything frozen on Earth.
And then also take a look down at the bottom. We have the geosphere and the lithosphere. And we have 2 terms there because in the book and in a lot of the material that we talk about in class, they use those terms interchangeably. So they mean the same thing, solid earth, rocks, fossils, etc. So when you see either one of those terms, they're referring to the same thing.
All right, so one of the things we'll have to practice here is trying to see what type of interactions we see between the spheres. So we'll give you guys one example, and then you want to pause the video and see if you can come up with the other ones. So you guys want to try and talk through the first one, a raccoon breathing. What spheres would you see interacting?
So if you were a raccoon breathing.
I would be alive because I'm a raccoon, so that would be the biosphere. And because I'm breathing, I'm expelling gas into the atmosphere, so biosphere, atmosphere.
Thanks.
Good.
All right, so pause the video, take a look at the next 5, and see if you can come up with some answers we can talk about in class the next day, but be ready to start talking about these with your classmates. All right, so one of the things we haven't really done yet is we have to define what a system is, because we talked about the spheres, and we have to start talking about these spheres working as systems. So your textbook definition, it's just a group of interacting interdependent parts, and they form this complex whole. And we always like to think about matter and energy. So you guys want to talk about the picture we see down here and how it's a system?
No? Okay.
It's all yours.
So what I see there is the water cycle. And so recognizing something about how water then moves through different pieces of a whole, but then when you break down, you're able to look at the different parts to it. And so you can see how matter might be moving through water. Water molecules might be going into the cloud or into the air, coming back down and turning into rain, falling on the ground, maybe as some runoff, and then evaporating back up. Recognizing that the energy maybe involved is then sunlight coming in to be able to then move those particles around.
Awesome. And there's systems all around us, and it depends on just how you define what your system is going to be, what you're describing moving of matter and energy. And from here, we've got 2 types of systems.
Yeah, so the first type of system is referred to as an open system, to where we have matter going in and matter going out. We also have energy in and energy out. So if we think of a hurricane, how would that be an open system?
I'm thinking like you can add water to a hurricane, like from the oceans, and then the water leaves because it rains.
So just like the water cycle that we saw on the slide before that Ms. Guest explained.
So matter's going in and out. All that water's moving in and out. Now energy, like it gets heat, like you get hot water from the ocean, so that's kind of some heat energy.
And then it heated up because the sun heated it up,
Okay.
right?
And then it loses energy too, like when it dissipates or like it dies down, it
Absolutely.
loses energy. So that's energy going into the system, energy going out of the system.
And that's an open system.
Now this closed system, it's pretty rare. We don't see it too often in nature. So it's basically no matter is going in or out. And then energy can go in and energy can come out. So the classic example is like a car radiator. Do you guys know how a car radiator works?
I do not. Can you explain?
Yeah.
I'm totally clueless on this stuff, but I think I know something about it. So basically, it just has a closed loop where water just cycles, and the same water keeps cycling throughout. And as you drive, the air kind of cools the water down in that closed loop. So you're starting with the same water, you're ending with the same water. No water's going in or out.
But the energy is definitely being transferred because you're losing heat and you're gaining heat from the engine and then losing heat while you're driving.
Perfect.
Kind of like my closed water bottle that I left in my car today.
Exactly.
Where I had it cold in the morning, left it in the car. I'm sure when I get out there, since it's a warm day today, it's the energy then going in has heated up the water where it's not going to probably be drinkable when I get in the car.
That's perfect. It might smell bad too.
yeah, probably.
All right, so the next, if we look at Earth as a system, this is just the same slide but a different picture. We've got energy coming in from the sun and energy going out into outer space. And most of the matter on Earth is pretty much staying here. A little bit of stuff we're shooting out with astronauts and spaceships. We're gaining a little bit when we look at meteorites, asteroids, all that stuff. So would this be an open or closed system?
Matter's coming in and matter can go out. So that means it would be open.
There you go.
That's it.
Yeah. All right. So these are two types of feedbacks that we see when we start talking about systems. So we have a negative and a positive, and they're kind of confusing on the terminology, but it's really straightforward. So negative feedback mechanism is basically where it's just maintaining the status quo. It's keeping the systems the same.
Absolutely. And the great example of that is just actually sweating, the human body sweating. If you're in gym class and you're running around and you're sweating, that act of doing that is your body maintaining its temperature of 98.6. And that's what it's going to do when you sweat. It's cooling your body down because you're exerting a lot of energy.
And so a positive feedback, it actually drives change. So one example is, say if it gets warmer outside, the glaciers can start to melt, which exposes more soil, and soil actually absorbs a lot more heat. And so the temperature is going to keep going up. And I think we got cut off a little bit there. If we had the temperature keep going up, we're going to
More glaciers are going to melt, the temperature gets warmer, and the cycle just continues, and the temperature continues to get warmer.
So a positive just means it's driving change, like it's a positive change going on. Okay, so we've got an example here of a volcano, and we want to talk about what spheres are interacting in the volcano and maybe what type of feedbacks are taking place here too. So let's take a look at one example that they come up with here. Maybe.
Lost our camera.
Oh no. Oh, come on, big money.
All right.
Your internet connection's kind of getting...
Oh man.
Should have updated your computer, Mr.
What are
Baldwin.
you talking about? Oh, it says update. Yeah, you're right.
Unbelievable.
It's just unprofessional.
Can't believe it.
Ah.
I feel like I'm like a robot.
I'll have to put this in the blooper video. Let's see if this works. Hey, there we go, and we're back.
Oh, awesome.
All right. Yeah, I blame that one on Mr. Z. So if you can take a look, right at the beginning, magma moves up to the surface through the ground, the geosphere, and erupts lava onto the Earth's surface. So it's geosphere again. So you're interacting within the same sphere, which is totally fine.
And you're also getting gas that's coming out as well, so then
You're
you're
ruining it for
interacting.
everybody, man. We're probably doing that next.
Oh, that's
Come
right.
on.
That's right. Why did you?
God.
Why did you stop me?
Sorry.
So like Mr. Z totally ruined for everybody. Gas in the form of water is going to be from the hydrosphere, and it's found in the magma, so part of the geosphere, and it's released out in the atmosphere. You want to ruin the next one too?
It's all right. All right.
Go ahead.
Waiting on you. Man. Yeah,
Me?
go for it.
All right. So if we take a look, the lava flows down the hill and destroys plants and animals. So that's pretty straightforward. The lava, again, is the geosphere, and now it's interacting with the biosphere. So, I mean, I think you're probably getting the hang of it with the sphere interactions. We've got a few more here, but it's really just kind of review from before.
There you go. And we got another feedback here. So
we
our
got
feedback, it's possible a positive feedback loop because ash blocks the sunlight, which causes a decrease in the temperature. So it's driving that change. If there was more ash, you'd get lower temperatures, and then keep that change going. All right, possible negative feedback too, though. So there's different possibilities depending on how you define it. If you have carbon dioxide released from the volcano, acts as a greenhouse gas that can increase the air temperature. So that's something that would maintain that status quo, keep it the same going on.
I would be wondering too if then this kind of scenario would be more of a short-term change or a long-term change.
Yeah, and there could be differences between it. You could have a short term of ash falling, long term of carbon dioxide. All right, so that's it. If you guys go to the class website, there's going to be a quiz that's right about this slideshow that we had here. And the quiz is auto-graded, so you get your answers right away. Take it as many times as you want. It's really good practice, and be ready to talk about it in class tomorrow.
And go back and watch the video if you were confused about anything, and come to class tomorrow with any questions that you have. All right.
That's all we got. See you guys later. Man, you blew it, see?
How long was it?
I don't know. It felt kind of long.